Hey, hi, this video is going to cover simple equations. The learning goals for this video are to understand how an equation works and to understand the golden rule of equations and apply the rule to solve simple equations. So here's an example of a simple equation, and we're going to use a balance analogy to this. The equation here is 2 times x plus 4 is equal to 10. Now, I don't know what that x represents. I don't know what that number is. All I know is that 2 times whatever that number is, when you add it to 4, it makes 10. Now the important thing is, here, this is an equation because we've got an equal sign here, which means that 2x plus 4 is the same as 10. Now if we think about it in terms of weights, okay, here we have 2x and 4 is equal to 10. So you notice that the balance here is level, so both sides weigh the same. And the rule is when we're solving an equation, when we're trying to figure out what this x represents, is that both sides always have to be the same. Okay, the balance must always be level. So the strategy that we're going to use is, well, if I only have x somehow left on this dish, and then a certain number of blocks left on the other dish, then that way, whatever is left on this side is going to weigh the same as x, which is going to be what it's equal to. So the strategy here is I'm going to take stuff from one side and take the same stuff on the other side. That way, the balance is always flat. Okay, it's always level. So here, I want to get rid of these 4 blocks here. Okay, so I'm going to get rid of these 4 blocks. But the only way to keep the balance level is if I take 4 blocks from the right here. Okay, poof, they're gone. Now I'm just going to write down what I did there. I took away 4 from this side of the equation, which we call the left side, and I also took away 4 from this side of the equation, which we call the right side. Okay, and look what we have left. We have just 2x here. So we have 2x because the plus 4 minus 4, it's like they subtract out. That's equal to 6, which is also 10 take away 4. Now, if I take half the stuff from the left away and I take half the stuff away on the right, okay, it should still be level. So that's what I'm going to do. I'm going to take half of this side and I'm going to take half of the stuff on the right side. Okay, so I've basically just split it in 2, okay, or I've basically just divided both sides by 2. And the way that we write that down is we're going to divide both sides by 2 like this. And you notice that we only have x left, right? Because 2 divided by 2 makes 1, so we just have 1x. And then 6 divided by 2 is 3. Right? So this, because the balance is equal now, I can say that x is equal to 3. And if we check the equation here, 2 times 3, which is 6, plus 4 is equal to 10. Of course it is. Okay? So you notice that what we did here when we're solving equations, we just did the opposite things, right? You notice here we have this plus 4. We took away 4. We see how 2 is multiplying with x, so we divided by 2. So when we're solving equations, we are doing what we call the inverse operations. And inverse is just fancy talk for opposite. Okay, so that's the strategy that we're going to do here. We're going to do the opposite things. And this leads us to the golden rule of equations. So whatever you do the same thing to both sides of the equation, right? You notice that the green writing here is on both sides because we're always doing the same thing to both sides. All right, so let's take this back to the realm of theory here. So we have x plus 5 is equal to 11. All right, so I want to do the opposite things so that we can have x all by itself on that dish, what we call isolate, right? We're going to isolate x, okay? So I'm going to take away 5 from this side, right? So I'm doing the opposite thing. But whatever I do to one side, I have to do the same thing on the other side. Right? So the 5 take away 5 is 0. That's gone. That's the whole point. So x is equal to, and then 11 take away 5 is 6. Now, of course, that's true because if we just figured that x was 6, 6 plus 5 makes 11. Of course it does. Okay? So I know it's very simple right now, but this is the exact same thing that we're going to do for much harder equations, which is really the main goal. Here, though, x is on the right side. No problem. I notice that there's this minus 7. Okay, so I'm going to add 7 to both sides, because that's the rule. Right? So negative 10 plus 7 is negative 3, and that is equal to x. Here, 4 times x is equal to 36. So here, 4 is multiplying with the x, so I'm going to do the opposite of multiplying, which is dividing by 4. I'm going to do the same thing to both sides. So x, because 4 divided by 4 makes 1, so I have 1x, I just write x. X is equal to 36 divided by 4 is 9. All right, last example here. X is being divided by 3, which is equal to 4. So I'm going to do the opposite of dividing by 3, which is multiply by 3. But I have to do the same thing to both sides. So 3 divided by 3 makes 1. I can use this striking. It's just a lot of fun to divide them out. So 3 divided by 3 makes 1x. I just write x. And 4 times 3 makes 12. All right. So that's how we solve equations. We do the opposite, or what we call the inverse operation to both sides. Okay? So these are simple equations. But what happens when we kick it up a notch and we have adding with multiplying, like in this example here? Well, this is the exact same example as what we did before, but we're going to do without the balance here. So we're going to do the inverse operation in reverse order of operations. So that means instead of usually doing adding and subtracting last, right, in BEDMAS, we're going to deal with them first because we're doing opposite stuff. Okay, so we're doing the reverse order. So here, I'm going to focus my attention on the left side here because that's where the x is. X is being multiplied by 2, and it's also adding with 4. So to solve this equation, I'm going to focus on the adding first. So I'm going to take away the 4. But what I do on one side, I have to do the same thing on the other side of the equation. So what I'm left with on the left here is just 2x, because 4 take away 4 is 0, is equal to 10 take away 4 is 6. And then now 2 is multiplying with the x, so I'm going to divide by 2, but I have to do it on both sides. Right? So 2 divided by 2, okay, just makes 1x. I just write x, and that's equal to, and then 6 divided by 2 is 3. Let's look at part B here. I notice on the left here is where the x is. It's being divided by 2 and then also subtracting by 5. So I'm going to focus on the subtracting, do the opposite, which is adding by 5, and I got to do it to both sides. Okay. So what I'm left with here is just x over 2, and that's equal to 8 plus 5 is 13. Now, x is being divided by 2, so I have to do the opposite, which is multiply by 2 to both sides. Right? So that 2 and the 2 will divide out. So I'm left with here x is equal to, and then 13 times 2 is 26. All right, here we have x is on the right here, no worries. Right? But I see here it's got a 3, it's a positive 3, so I'm going to take away 3, but I have to do it to both sides. So I'm left with, on the left here, that's 5, and that's equal to, now I'm just left with negative x. Now, this is the usual part where we probably divide. I don't see a number there, but there is an invisible 1. So that means I need to divide both sides by negative 1. Right? So that the negative 1 and the negative 1 will divide out. So I'm left with, I'm going to write over here, x is equal to, and then 5 divided by negative 1 is just negative 5. All right, last example here. X is on this side of the equation, so I'm going to focus here. I notice there's a 7, and then x is also being divided by 5. So I'm going to first take away the 7 on both sides. So here, this is gone. That 7 is gone, I mean. So I'm just left with x over 5, and that's equal to negative 3. X is being divided by 5, so I'm going to multiply by 5 on both sides. Again, we do the opposite. So 5 divided by 5 makes 1x, so I just write x, and that's equal to negative 15 when you multiply it out. Okay. So let's just focus on the success criteria here. So make sure that you identify the side where the variable is, because that's where you focus on. Now the goal is to remove the numbers on the side where the variable is, which is what we call isolate, right? We're going to isolate x by performing the inverse operations, right? So we got to make sure we do opposite stuff. And then you notice just then in multi-step problems, we've got to do backwards BEDMAS. Okay, very important. So we deal with the adding and subtracting first. So why don't you give these simple questions a shot? Okay, pause the video, give it your best go, and then when you're ready, press play. Okay, we're going to take these up. Notice that x is on this side. I notice that x is being added with 9, so you just take away 9, right, on both sides. So here, 26 take away 9 is 17, which is equal to x. Here, 6 is multiplying with the x, so you're going to need to divide by 6. You got to do it on both sides. And so 6 divided by 6 makes 1x, which is just x, and 10 is on the right. Here, x is being subtracted by 4, so we add 4. We got to do it to both sides. So x is equal to 16. All right, let's hope you got that right. Let's look at some harder questions. So again, focus on the adding or subtracting first, and then the multiplying or dividing second here. Okay, so again, pause the video, give it your best shot, and when you're ready to take it up, press play. All right, let's take this one up. So again, x is on the left here, so we're going to focus on getting rid of this plus 3 and then that 2. So we're going to take away 3. We're going to do it on both sides. So here we're left with 2x on the left, and that's equal to 5 take away 3, which is 2. Now this 2 is multiplying with the x, so I'm going to divide both sides by 2. So the 2 divided by 2 just makes 1x, and that's equal to 1. Over here, x is on the right, so I'm going to focus my attention here. I'm going to get rid of that plus 7 and then deal with this dividing. So plus 7, I'm going to take away 7 on both sides. So 10 take away 7 is 3, and that's equal to x over 4. Now I got to get rid of this divided by 4 by doing the opposite, which is multiply by 4. So on the left here, 4 times 3 is 12, and then the 4s will divide out. So you just have x, so x is equal to 12. All right, last one here. I noticed that the x is on the left here, so I focus on getting rid of this 3 and then divide this number out. So I'm going to take away 3 on both sides. So you're left with here negative 4x. A lot of people forget the negative. Don't forget the negative. Is equal to 20. Okay. Going back to that, don't forget the negative. Keep the signs in front of the numbers, right? It's very, very key. Now we're going to divide here because negative 4 is multiplying with the x. We're going to divide by negative 4. So the negative 4 and the negative 4 will divide out. So x is equal to negative 5. All right, let's sum things up here. So again, equations are like balances. So both sides must remain equal at all times. Okay, so that leads us to the golden rule. So in order to keep things equal on both sides, whatever you do the same thing, okay, on both sides of the equation. Okay. Now, the main strategy is we perform inverse operations in reverse BEDMAS. Okay, so let's write BEDMAS backwards, which is SAMDEB. Okay, so don't forget SAMDEB when you're solving an equation. All right, so hopefully this video has shed some light on solving equations, and feel free to watch it again if you need to. So best of luck